Decided to solve Eaton's robot arm cost analysis dynamics problem. The robot arm we are investigating is very similar to the one shown on the right. It is called the FANUC R2000 IC. Its purpose is to move supercharger parts from station A to station B and replace human labor that is currently costing Eaton $50 per an hour. We have investigated how long it will take for the robot to pay for itself in terms of labor costs saved. We sought to find two main things from our calculations. First, we calculated how long it will take the robot arm to break even and pay for its cost of $125,000. Second, we were asked to find the acceleration and the velocity of the parts at some instant within their motions as they are being held in the arm. In addition, we were asked to break the results into factors of safety of 1, 2, 3 regarding the design limits of the robot arm's maximum angular velocities.
Our first step in the numerical analysis of the robot arm's value was to gather all of our required information about the dimensions, price, and design limits from Eaton employee Doug Brulard in the FANUC spreadsheet about the FANUC R2000 IC. Next, we simplified the motion into three simple ones with several models, two of which are shown, and implemented the related dynamics equations. Our last step required us to convert our time calculations in each factor of safety to terms that describe the robot arm's effectiveness with human wages. Here we have the results of our numerical analysis of what would occur if the robot arm replaced the human currently moving the parts. In the leftmost column, you can see that the parts are broken out in terms of factor of safety. The two columns to the right of that show the velocity and acceleration as the parts are moved over the divider. The last three columns put how effective and efficient the robot arm actually is into perspective where, when compared to the 20 seconds the movement originally took, we can see that using the robot arm is a vast improvement to a human mover.
There were two main assumptions that may result in some small sources of error in determining whether or not using FANUC's R2000 is a cost-effective decision. The first one is that we assume that there were two relatively instantaneous periods of acceleration at the beginning and ends of each motion, which when accounted for would add very minimal amount of time to the movement of the parts. The second assumption and source of error is that the J2, J4, J5, and J6 arm sections, the longitudinally rotating aspects of the arm, do not impact the velocity and acceleration of the part. This is a reasonable assumption, but not fully true, since any force on the part by the arm has the potential to change the velocity and acceleration of the part. In order to determine the financial effectiveness of the robot arm, it simply has to break even before its 2-year warranty expires. Eaton, to determine this, has to find how many parts are moved between the stations in a 2-year period and verify that this is a higher number than the amount of movements in any of the three factors of safety. Furthermore, if this needed to be calculated again, the break-even time should include our possible sources of error.